All right, cool. Hey everyone, my name is Tony Bone, and this is my presentation on encapsulation information hiding. Not illustrated by me. I got these pictures off the internet. So what is encapsulation and information hiding? So encapsulation is basically the bundling of data with methods that work on that data. So like Java and other languages that use object-oriented programming rely heavily on encapsulation. And then I'll be able to expand on this later in my talk. So in computer science, information hiding, right? It's a principle of like segregating the design aspects, the design decisions that you want to put into your computer program that are most likely to change. So those types of things you'd probably want to keep separate from the rest of your program. And when you keep it separate, it allows it to, you want to protect it from anyone that might want to access it outside of that program. So let me preface this real quick, all right? There's a constant debate about whether information hiding and encapsulation are the same thing. And for like, at least our intents and purposes for this presentation, they're not necessarily the same thing, but oftentimes they're used together, so that's why like a lot of people like to interchangeably use the terms. So here's the table of contents for the presentation today. I'll like constantly give you guys a timeline of where we're at. So at first I'll give you history, and then I'll talk about steganography and encapsulation. And then in the middle we're going to do a stretch because these tend to get long, and then, yeah, that's my favorite part. And then we're going to talk about access modifiers, information hiding applications, and how it intertwines, and any questions you guys might have at the end. So here's a little lesson in history. Information hiding first came to public attention in 1972 by David Parnas when he wrote a paper called On the Criteria to be Used in Decomposing Systems into Modules. What a mouthful. Information hiding is characterized by the idea of secrets, like design and implementation things that you have that a software developer hides in one part of their program. And to keep it just, like I said, segregated from the rest of the program. Information hiding is part of the foundation for both object-oriented design and structured design, and I'll get to how those play out towards the end of my presentation. So the first use of the term steganography was in 1499 by Johannes Trithemius in his book Steganography, which is about cryptography and steganography. And actually he designed it so it was disguised as a magic book, but it was really about those things. As Sarah mentioned last week with her talk on steganography, it's a technique of hiding data like secretly, right? In like a non-secret file or an image or whatever you want in order to avoid the detection, right? And the secret data is then extracted at the destination. The use of steganography can be combined with encryption as an extra step to keep that information extra safe. The word steganography is actually derived from the Greek word steganos, which means to hide, like hidden or covered, and graph, which means to write. So steganography can be used to conceal almost any type of digital content, including text, image, video, audio, you name it. The data can be hidden inside almost any type of digital content. So the content to be concealed through steganography, called hidden text, is often encrypted before being incorporated into the confusing-seeming cover text file or data stream. If it's not encrypted, then usually it's just hidden a bit more carefully. So then you can increase the difficulty of someone trying to detect the secret content. Steganography is practiced by those who usually want to just convey a secret message or code. While there are many legitimate uses for steganography, because we are the ethical hacking club, there are also people with malicious intentions, like malware developers, who have also used steganography to their advantage. So different forms of steganography have been used over the years. Almost any technique, and include almost any technique of hiding a secret message in an otherwise an otherwise harmless container, right? For example, if you use like invisible ink on like a drawing or a picture that would be otherwise inoffensive, but then like eventually it shows up later, right? Or you could hide documents recorded on a thing called a microdot. So that's a microdot right there, and that thing can be about like a millimeter. So you can, like, to the naked eye, you can't see any information, but if you were able to extract the information from there, it'd be really hard to find. And even in like different multiplayer games, people are able to like, you know, use steganography. Like if you're playing Call of Duty and then you shoot the wall and it has like a certain like outline that you want your homies to see, but then they see just a bunch of bullet marks. But yeah, steganography. All right, in modern digital steganography, data is first encrypted or like obscured in some way, and then it's inserted using a special algorithm. And usually they put it into like a JPEG file, but you can, like I said, you could put it in basically anything, any type of file. The secret message can be embedded into ordinary files in a lot of different ways. One technique of hiding the data is by representing it in the pixels that are repeated in like the row of an image file. So it's almost like when you look at these images, they look basically the same, right? Like visually, but then if you were actually like, you know, physically looked at each individual pixel, then you could see, and you looked at like the code for it, you'd see that there's a hidden data within there, right? And it's identical to the original image, but there's like some noise that's in there, right? And there's also the practice of adding a watermark. Like if you guys ever seen like memes and like if they want to keep it like original, then you know they put their watermark down so then they know, oh, this guy stole my content because my watermark is in there, you know. So that's one form of steganography. While there's a lot of many different uses of it, including embedding sensitive information, one of the common techniques is putting a text file into an image. When this is done, anyone viewing the image should not be able to know that there's anything in there. And this is accomplished by storing the message in like the least significant bits of the file. This process can be completed manually, or if you have a steganography tool, then you can use that to embed your secret message in an image. Before I move on to some steganography techniques, here's some terminology that you'll know. It's like fairly straightforward. Payload is just whatever info you're trying to convey, right? And then the carrier, also known as the stego container, is like anything that would like store the payload, right? And then the stego system is just whatever means that you have that you're going to be delivering the information. The channel is going to be like literally the means that you use, and the key, which you would most often use, like I would use a key if I was going to try to relay some information, but it's not always, you don't always need an extraction key, but it's definitely a good idea to use. So here's a bunch of different steganography techniques. So the first one is LSB, or least significant bit steganography. So as you can see in the image, the original image and the stego image look very similar, but then see how like the least significant bits are slightly changed to have that hidden message cat, right? And the second one is discrete cosine transform, or DCT-based steganography. So it's a type of like LSB steganography, but instead it just uses like sine waves to provide to secretly encode like these coefficients that you want within the code that you're trying to relay. And then payload embedding is like a method where you have your payload, right, and it's encoded into the carrier, but when you deliver it, there's some sort of algorithm that both parties know that like is relayed beforehand before they get that information. And several payloads can be independently coded and have the same carrier that embeds the information. There's also wideband methods, which have these two. There's one pseudo-random sequence method, which is basically you're relaying the message through like some sort of pseudo-random sequence. Obviously, it's called pseudo-random because it's not random. You have some sort of method to the madness. So there's that, and there's frequency hopping, where it uses it uses a pseudo-random technique to change the frequency at which the message is being relayed. So then it's harder to track it down if someone was trying to hack into it or get to it. Here's some examples of steganography and malware. So we have Microsyn, NetTraveler, and a bunch of other ones. I won't go into all of them, but I'll get into the loader 0T. So the way that zero-T works is like the malicious loader penetrates the victim's system through malicious memes. What a surprise, right? And it loads a physical payload from a bunch of bitmap files, right? So you see those, right? And then the program will extract the malicious files from the BMPs. And so like these images, right? They look good, right? Yeah? 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 Wrong. Wrong. You thought. On the face of it, these 3 BMP files look like fairly fine, right? But they are more than just regular images. Obviously, you know, I mean, this is the talk. They have some secret message in it, right? So is there a way to determine if there's a secret in the message? Of course. There's several ways of doing so, simplest being like a visual attack using a program. So it's based on forming new images from the source image containing the least significant bits of the color pattern. So in the next one, I'll show you the picture of Steve Jobs taken apart. So did you know that Steve Jobs is short for Stephen Jobinson? He's not related to Stephen Parkinson, but he's there. He's a real person. Anyways, now you can apply the visual attack to an image and construct new images from it, right? And as you can see, like it's very obvious where those like streaks are. That's where the encoded image would be once you've like extracted the images out. So it's simple in that an analyst, even like an average user, could probably figure out like that there's an embedded message in this image, right? But it is rather difficult to try to figure out like how you would make a program that would be able to differentiate these parts out, right? So the way that scientists were able to figure out how to, over time, they were able to figure out that when there's like a high entropy in an image, which basically means like there's a high density of like data, that shows that there's some sort of like hidden image within that section. So the sections that you see have like high entropy. And then it's true that like, this is true in most cases, since the container's capacity is limited, like the payload would be compressed or encrypted before you encoded it, right? But that would increase its entropy, which would make it more obvious in like an image. Steganography also exists in music. So this guy, Gaspar Schott, he basically like mapped all the letters of the alphabet to like these like musical notes. And so if you were to play it, it would sound really terrible, but you know, he can spell any sentence, so take that. All right, this is another example. Since everyone can read, encoding text in neutral sentences is doubtfully effective. So you have a volunteer who can tell me what it says. It already says it on the screen. No? Okay. It says secret inside. That's what it says. This is my favorite one. So it says she believed, but I bet y'all won't be able to figure out the other one. He lied, because men are liars. Now we will be talking about encapsulation. So here's the table of contents just to give you guys an idea of where we're at. They don't think it be like it is, but it do. That's my favorite quote from L. Ron Hubbard. Yeah. As I described before, encapsulation is just like consolidation of data. It's like when you just have like a combination of code and like whatever like operable data that you have that you want to like do your methods on, right? And so like the key thing about this is protecting your data. Like if you guys have ever done like a Java class, then you know like, oh, you want your variables to be private, and then you might make some functions private or public depending on like the kind of access that you want it to have. So think of it like a pill or a capsule where the variables and the data are inside the class, and that represents the encapsulation of it. Here's a class that I made called encapsulate. So you just have your private variables, and then you have your getters and setters that are able to manipulate it. And then you have the last one, which just sets the name to Tony Bone. That's me, if you didn't know. And yeah, do with that what you will. So here's some advantages to encapsulation. First one is data hiding. So like I said, information hiding, encapsulation, they just like bob and weave through each other. So this is one of the applications where you'd want to use it. The user would have no idea about like the inner implementation of your class, and like that's the whole point. The user shouldn't be able to directly access any variables. But if they wanted to modify it, then they would do it through like the formal public getters and setters, or whatever they want to use. Another advantage is increased flexibility, because let's say like you had a file that you wanted to make read-only, then you would like move out you would omit the setters for like age or whatever, right? And then if you wanted to do it as write-only, then you would take out all the getters, because you shouldn't be able to access any of the information. Another benefit is the reusability of it. So basically, like, let me see. You can easily change like whatever aspects of your program that are like, usually you'd encapsulate certain parts that tend to change, right? So if, let's say there was a part of the program that was really like integral, then you'd want all of those to be like public methods. But then if you had like a part of the program that you knew, oh, this is probably going to change in a few months, then you probably wouldn't want that one being you wouldn't want a lot of the functions and parameters in it public, because then there could potentially be other programs that are utilizing it. And so just to like minimize the amount of potential for like messing up your whole program, it's just better to keep certain things private. And then we got the mid-presentation stretch. If you guys are not limber, stretch. I'm gonna stretch because I wanna stretch. Yes, swing your arms, kick your legs out. It's been a long day. Wednesday, we're almost to the weekend. All right. Everybody feeling good? Yes? 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 I want to hear a yes. Yes. Nice. Okay. So these are the different types of access modifiers that I mentioned before: private, none, protected, and public. So here's just a few examples of it. So with private, this is the most restrictive and commonly used, like I said. You would only have access to like those variables or those methods within the same class. And then subclasses or any other classes that want to use it would just not be able to. So this would be your default. This would be your go-to for like any program that you're writing, and then you'd probably figure out, oh, I can utilize this here. I can make this public or protected. But otherwise, it's always a safe bet to do private. You can almost never go wrong with that. So when you have no modifier, you can access it within your class and all the classes that are within like the same package as that class. That's why it's that's why a term that people use is like package private for no modifier. And then protected allows any variables that you have to be accessed through like a subclass, right? So usually any subclasses or like other internal methods within your program can use it. Also, any packages that a subclass is in can also use it. Yes?
What's a package?
A package is just like the program, like, yeah. Okay. This is the least restrictive access modifier. It's just public. It has access to all like the classes, so it would be really rare that you would make an attribute that would be public. Like, you would really want to think twice about it, because it's like, why would you want your variables to be public? So it's almost never good. When you make it public, like, it becomes the API of your class. So yeah, just be careful with it. And here's a little chart that helps you like understand the modifiers a bit more. So you see like if it has access, if people can access it through the class, the package, subclass, other classes. And well, would you look at that? We're almost done. Home stretch. Y'all are basically experts now. But here are going to be a few tips on how you can actually implement information hiding. So when you can use it is like if you have a list of design secrets that you want to hide, you can begin your design by listing like the design secrets, and then the most common kind of secret is like a design decision that you think might change in the future. So anything that has like a lot of variability, usually you just want to keep it, you'd want to hide your information, hide that class unless you like really need to use it. And then you can separate each design secret by assigning it to its own class or subroutine or other like design unit. And then you can encapsulate each design secret so that if it does change, then the change doesn't affect your whole program, it doesn't explode. doesn't literally explode. Hardware dependencies are like one of the things that implement like potential changeable design areas. So for example, like with Apple and like Swift, Swift has a hardware dependency because you would only use it for like Apple products. And then let's say there was a game that was only playable on PC, but then you couldn't play it on like a Mac or console plebs. I had to say that. Okay. And then there's also input and output formats, both machine readable and end user readable. Use of non-standard language features and library routines. Difficult areas of like implementation. So if you know like you're writing a program and you're like, I'm not really sure how this is going to work out, it's almost always the best idea to just encapsulate it and keep it like isolated so you don't try to implement it with your whole program and, like I said, potentially blow it up. And then also complex data structures that are like used by more than one class, or data structures that you haven't designed to your satisfaction. Other changeable designs are complex logic. Complex logic can be almost as likely as complex data structures to be to change, to have like variability when you're writing it. Also, global variables, probably not really needed that much, but you can almost always benefit from being hidden behind like some sort of access routine. And there's also data size constraints such as array declarations and loop limits. And lastly, business rules such as like laws that, like for some reason, if your program implemented some sort of like law, then the laws change. So you might want to change that. And then lastly, information hiding is the key factor behind structured design, object-oriented design. I apologize, it's kind of hard to read. It says encapsulation, modularity, abstraction. So in structured design, the notion of black boxes comes from information hiding. It's kind of like when you see like I should have put one up. It's like I'm going to draw it. I'm going to draw a black box. So it's kind of like, I know you can't, okay. Oh, yes. So black box is pretty straightforward. It's not like super hard. It's just like when you have some sort of thing where you have like maybe like a standard in, and then I don't know, you have like a bit stream or something going in, right? And then you just have like an out. So this black box, it's kind of like, super mysterious. I don't know what's going on in there. But basically, encapsulating your stuff in a black box keeps it like isolated, so you know, okay, this specific part of I know exactly what this specific part of my program does. I'm not going to touch it. If I do touch it, I'm going to take it out. And yeah, so that's a black box. And then, okay. So, yeah, that's it.